All right, guys, so new packet and trig, and I need a calculator. Our learning targets today are very simple. It's simplistic in that there's just these two that are part of 4.0. The learning targets are all listed, I think, inside the front cover of your packet. The first one says, I can find missing sides and angles in right triangles. And then I can find exact values of missing sides and angles of 30, 60, 90, or 45, 45, 90 triangles. All right. I put a little thing down here. Everybody know that this Greek letter is theta? Okay, do you remember seeing this ever in trig or algebra 2 or geometry? Okay, we use this a lot. I found this on the website. I was trying to find a list of Greek letters that they use because sometimes I don't say the right names for them. But it says here, you know, everybody uses this in trig, so that's a theta. All right, so again, the mode only matters if you are pushing the sine, cosine, or tangent buttons. And for today, everything we do will be in degrees. All right, so some basic review. When you have a right triangle, tell me about the vocabulary. What's going on? Please stop moving things. Okay. I don't know what's happening. Hang on 1 second. I need to get a pen. Seriously. All right, now I suddenly have a pen. I don't know how that happened. And it won't stop writing. Okay, what can I do here? Let's try, first of all, let's turn off the reading. All right, guys, so when you have a right triangle, there's some things we need to be very comfortable with. And the words we need to be comfortable with are leg and hypotenuse. Everybody good with that one? That the hypotenuse is the longest side. It's always directly across from the right angle. Really? So on these would all be the hypotenuse, right? The other two are legs, and then it's going to matter where the angle we're referring to is. So I'm going to randomly say that this is theta on this one, and this one is theta on this one, and let's say this one down here is theta on this one. Once we have chosen one of the acute angles to be at, and I usually do this cute little smiley face to say I'm standing there. I'm standing at this one, apparently frowning, and this one. Okay, then what we want to decide is which of the two legs we are standing next to or adjacent to. Okay, adjacent is next to the angle, and then opposite is all the way across from us. So on this picture right here, the first one here, if I'm standing down here at this acute angle, I am standing right next to this leg. So this would be called the adjacent leg. And the other leg that makes the right angle is all the way across from me over here, and that would be the opposite leg. So on this one, where is adjacent and where is opposite? If my angle that I chose to stand at is up at the top here, what would the bottom be called down here? That would be opposite of where I am. And right over here would be next to. Now remember, I already identified the hypotenuse right away, so this is the adjacent leg. And the third triangle down here, if I am standing in the bottom corner here, the one that is at the bottom is adjacent, and across from me over here would be opposite. Is everybody okay with that vocabulary now? All right, so then we come to the idea that you can write a ratio and find all these missing sides and angles using right triangle trig. Now, your teacher in geometry may have used this phrase, so ka toa, to help you remember that the sine of an angle is equal to the opposite leg over the hypotenuse. Okay, so that's sine, oh, this pen, equals opposite over hypotenuse. That's what the so. Ka is cosine, which is abbreviated COS, of an angle is equal to adjacent leg. It's the ratio of the adjacent leg to the hypotenuse. And that's CAH, or Ka. And then the last ratio is the tangent, which is abbreviated TAN, of an angle is equal to the adjacent leg. Sorry, it's opposite over adjacent. I'm just worried about other things. Opposite leg over adjacent leg, which is TOA. The other thing is, on your calculator, they are always in that order, sine, cosine, tangent. Okay? Everybody see what I'm talking about? On your calculator, it goes sine, cosine, tangent. Yes? And some teachers teach Oscar had a handful of apples for how those ratios go. Okay? Does anybody need me to write that up there, or are you okay with the SOHCAHTOA thing? I just remember SOHCAHTOA and then I write it across the top of my paper right away. Anybody need more help memorizing those ratios? Just a little background. The reason this works is because every right triangle that has, for example, a 32-degree angle is similar to every other right triangle that has a 32-degree angle. Do you remember in geometry there was a theorem called AA, angle-angle similarity? So if you have a 90 and say a 32, then every triangle has that same ratio. So those ratios of sides are programmed in your calculator. All right, so that's a little bit of why this works. So this just wants you to find the value of the trig ratio. A trig ratio means a fraction, guys. A ratio is a fraction. So it says stand at X down here, put my smiley face, and find the tangent. Well, the tangent of X means I need the ratio of TOA, or opposite over adjacent. So in this triangle, 15 is the hypotenuse. From X, this side over here is opposite, and this side is adjacent. Everybody okay? It matters where you're standing for the opposite and adjacent. If I were to move to Z, then opposite and adjacent would switch. All right, so what is the ratio from X of opposite to adjacent? Would be 12 to 9. And they don't want you to do anything with it. It says find the ratio. That means leave it a fraction. It does reduces by 3 to 4/3, yes? Ugh, my pen. It's better than nothing. Okay, I'll be happy. All right, on this triangle, it says we're standing at C. So what is the 10 called, guys? Opposite, adjacent, or hypotenuse? The 10 is the adjacent, the 26 is the hypotenuse, and the 24 would be all the way across the triangle or opposite. Is anybody struggling with that opposite and adjacent thing? Okay, because it's super important, so if you don't get it, let me help you. Now, sine is so, sorry, it's not writing nicely. So for the ratio for sine, I need opposite over hypotenuse, so I'd have 24 over 26, which reduces to 12/13. How we doing? Everybody okay? Can you do these two real quick then? let's see, cosine of z, so I'm standing up here, opposite, adjacent, hypotenuse. Cosine is adjacent over hypotenuse, so what do I get? (28/35) reduces by 7 to 4/5. Did someone have that? All right, and tangent of x, x is down here. So our hypotenuse across from the 90 is this 50. Opposite of x would be the 48 and adjacent. And tangent is TOA, or opposite, oh my goodness, this pen, over adjacent. What do those reduce by? Just 2? 24/7? Are we good? Any questions? All right. Now, how to decide which ratio to use. Okay, so if they don't tell us whether we're supposed to use sine, cosine, or tangent, it says here, work from the acute angle that you're talking about, which we're going to label theta. It says label opposite, adjacent, and hypotenuse, and then decide which function uses the ones you know and the ones you are looking for. Okay? So now if you want to write some of that down, it says work from your acute angle, label OA and H, and then we're going to decide which function uses the things that we know and the things we're trying to find. Are we going to use SO or KA or TOA? And then we're going to set up the ratio, and we're going to do a little cross multiply and divide. Guys, when you have something like this, oh, that was supposed to be a 12. When you have something like this, I don't know about you, but I don't write on my paper that 7 times 12 equals 3 times x. I just do 7 times 12, and then I know I'm going to divide by 3. Does anybody else do that? Because you've done enough of these. You're thinking, I'm going to cross multiply these two and then divide by this one to get the x by itself. Okay? That's the idea we're going to use. So it says, when giving a trig problem, the first thing you want to do is label opposite, adjacent. Then you have the information. Okay, we already talked about that. So when you have this kind of a situation, I would say 4 times 7 divided by 5. Okay, so when I have this situation in a minute, I'm going to think of this as 7 times the sine of 36, and then divided by 1 will give me x. If I had this situation, though, what will happen? X is down here, so I'm going to do 9 times 1 divided by the cosine of 43. I don't want to put it there. Is everybody okay with what I'm talking about? I'm just thinking about the cross multiply and divide business. Okay, if the x is in the denominator, you got to go at it a little different than when x is in the numerator. Those are just some examples. And now we're going to try. Ready? All right, so this is the angle we're given. So this is our theta, the 61 degrees. You don't ever use the 90. As you have to have a 90 to be able to use any of this, but you don't use that as your angle that you're working from. The 15 is going to be called the opposite, and the x is on the hypotenuse. We know nothing about this adjacent side, right? So we can't use anything with an a in it because we don't have an x there and we don't have a number there. So what uses O and H? This is where we have to make a choice. Which function uses O and H? Yes, we have SO for sine. Then remember the ratio actually means the sine of the angle, which was 61 degrees, equals, and it stands for opposite over hypotenuse, which on this one will be 15 over x. Okay, so that was a lot if you didn't learn this in geometry. We labeled them, we chose the function, we set up the ratio. Everybody okay? And then to solve, can someone tell me how I'm going to type that in my calculator? Since the x is down on the bottom, I'm actually going to go 15 times 1 is 15, right? And then since it's equal to, and you could write this out if you need to, the sine of 61, I'm actually going to end up dividing. I usually don't write that step out. I just type 15 divided by the sine of 61. So we go to our calculator and we do 15 divided by the sine of 61. And I got 17 point, I don't remember what delta math does. Might do tenths. 17.2 maybe. I wish I remembered that. I should have looked that up this morning. It is tenths, thank you. 17.2. Oh, it says tenths right here too. Okay. Now, let's look at the triangle. Does that make any sense? Yes. Division, the order matters, right? 1 divided by 2 means you get half a pizza. 2 divided by 1 means you get 2 pizzas. So the order that we type it in matters. And you have to do the known 15 times 1 and then divided by the sine of 61. Is that better? Okay. Your answer should make sense for this triangle. Which side has to be the longest, guys? The hypotenuse, okay? So this makes sense. All right, let's go to the next one. If we put our smiley face at 67 degrees, across from us is this x over here. This would be opposite. What is the 16? It is adjacent. Across from the 90 down here is the hypotenuse that we don't know anything about. So which one uses O and A? SOHCAHTOA, TOA, tangent, uses O and A. Everybody okay with where I'm getting that? And then you're going to write the tangent of 67 degrees equals opposite. What's on the opposite side? Our x, right? Over adjacent, and the adjacent was the 16. Everybody okay with that part? Now, when I set this up as over 1, this time x and 1, when I go this way, I just get a 1x, right? Equals, and then it's this times this. So this time I just have to type 16 times the tangent of 67. Now, let me give you a little hint here. I always do the side times the tangent of the angle. The order you multiply doesn't matter, but if you put the tangent of the angle first, what do you have to do before you can hit times 16? You'd have to close the parenthesis or it won't do it right. By putting that closed parenthesis at the end, I'm being lazy and I don't have to actually close it, okay? Doesn't matter, same answer, but be careful. Does anybody remember what it was? 37.7? Does that look like a 3? Sorry. All right. Can you guys try these two real quick? On 11 and 12. This is the hypotenuse here and hypotenuse here. What's the x on this one called? Opposite. And the x on, or the 13 on this one would be adjacent, okay? So now if at the top I had written So, oh, it doesn't like the top. Maybe I can write at the bottom. So, ka, toa. So this one has an O and an H. That would mean I need to use sine. This one has an A and an H, which would mean I need to use cosine. Okay, then we always put the angle. And then it's O over H, so that would be X over 17. So what am I doing on this one? I just get 1x equals, and I need to multiply. I got 6.9. Did anyone else get 6.9 on that one? Anybody not getting 6.9? Natalie, did you got that one? Okay. This one, the angle adjacent hypotenuse means cosine. Cosine of 73 equals A over H. So this is the one we have to type funny, right? You have to do 13 times 1 is 13. And then divide by the cosine of 73. Got 44.5. Anybody else? Does that make sense? We should always be checking at the end whether it makes sense, but it's the hypotenuse, right? So it should be a big number. Okay, or bigger than with a side anyway. Can I skip 13 and 14? Are you feeling like you got this or not? Anybody? Everybody's okay? I can come back if I have time. 15 and 16 the same. Okay. I'm going to go on to number 17 where we talk about how to solve for a missing angle. When you are missing an angle, okay, so if I want to find, say, this angle down here, again, I might know this is the 90. I'm looking for this acute angle. I might know this opposite, this hypotenuse, or this adjacent. And what I'm going to do is I'm going to undo or solve for the angle. So we're going to use the second button on our calculator to use what's called the inverse function. If this one, I had been looking for this angle, again, over here would be opposite. This would be the adjacent, because remember, those are the legs, and this is the hypotenuse. Okay? So we're going to use the second button on our calculator. So for example, it might say when we're done, the sine of angle theta equals, we'll say 1 over 2. It's an easy one. Okay? What we're going to type on the calculator is the inverse sine of 1 over 2, and it's going to give us theta. Okay? So the sine of an angle equals, and then you're going to have a fraction or a ratio, and you don't have to reduce, it's fine. And then you're going to would type second sine to undo that ratio and find the angle. And this is one that we should know eventually from heart, but oops, I forgot second. Second sine of 1/2, or 1 divided by 2, should be 30 degrees, okay? Exactly. Now, most of the time, they're not going to come out exact. That happens to be a special right triangle. All right, ready to try this? So for number 18, the angle we're looking for here is theta. What would the 19 be called down here? Adjacent. And this is the hypotenuse. which if we have SOHCAHTOA, this would use A and H, which is cosine, right? So the cosine of theta equals A over H, or 19 over 28. Now, I don't care if you write it out, what you're going to type, or you just type it, but what you're going to have to do is undo the cosine of that ratio to find the angle. Oh my goodness, my pen is not happy. So again, second cosine, and then what was it, guys? 19 over 28. You'd think I could remember that long. Right, I got 47.3. Now, sometimes they will just do nearest degree here. I don't know what delta math does. Did anybody already do this? Do you remember degree or tenth of a degree? Yeah, it does say nearest degree here. I can't remember what delta math does. This would be 47 degrees if you did nearest degree, but I usually do nearest tenth of anything. But all right, find the measure of the indicated angle here. So from this angle, we have opposite and adjacent. We don't know anything about the hypotenuse here, right? Which one uses O and A? Tangent. So we have the tangent of some angle equals 9 over 25. It's O over A. So when we type it, we type second tangent of 9 over 25. And we should get an acute angle less than 90. Second tangent 9 over 25. I got 19.8 or 20 degrees. I just always feel like I don't like rounding to the whole degree, but it's okay. All right, I don't know what it asks in delta math, like I said. Can we try at least one of these or both real quick? Can you figure out which function it would be? Let's see. Ooh, this is the hypotenuse over here. If we are up here, this would be opposite. So which function is number 20? Sine. And because we're finding an angle, we'd be doing second sine of O over H. Just do that on my calculator real quick. I got 71.8 or 72 degrees. Anybody else? All right, and on this one, we have a hypotenuse given this time. And opposite, is that sine again? Oh, that wasn't very helpful. Yeah, 28.8. Ugh. Or 29 degrees, depending how you round. All right. The second part of the lesson today, and I know we're almost out of time here, is special right triangles. In addition, this is something that's all over the SAT. This is exactly what it looks like on the SAT. They use these all the time, okay? There are two possibilities. There's a possibility of a 30, 60, 90 being a special pattern that you should memorize. Even though this is given on the SAT, it is not going to be given in Hofbauer's pre-calc class, so you're going to need to memorize this pattern. And this is the pattern for a 45, 45, 90, okay? Now, it was my intention to show you why these work. I'm going to go kind of quick because what time do we get out, guys? Okay, so we have like 0 time. All right. if this was a 45, 45, 90, and you did Pythagorean theorem, hypotenuse squared, does that look right to everybody? X squared plus x squared would be 2x squared. Okay. And then when you square root both sides, the square root of x squared is x, but the square root of 2 is just the square root of 2. Square root of hypotenuse squared is hypotenuse. That's where that pattern comes from, in case anybody cared. Okay. So it's leg are equal if it's a 45, 45, 90. And the hypotenuse is x times the square root of 2. So let's find a couple of these. Number 2, if one leg is 14, where's the other leg on this one, guys? This is y, so this is 14 as well. And the hypotenuse, we know right away, is 14 square roots of 2, if we memorize that pattern. Everybody okay with that one? This is the next page in your notes, right? Okay, for number 3, if you're using the same pattern and you already know that this is 7 times the square root of 2, well, you take the square root of 2 off, and that means each of the legs has to be 7. Easy peasy so far? Okay. They do get a little trickier. This is a leg, yes. So this other leg over here is the same. So this is still square root of 10 over 2. That's weird, but that's okay. To get to the hypotenuse, the pattern says you take the leg and you multiply it by the square root of 2, right? Okay, now we got to use our brains. This becomes the square root of 20 over 2. What is the square root of 20, though? 4 times 5. And what is the square root of 4? This is just 2, so then the 2 divides out, and we're left with a square root of 5. You will have to do some of these ugly ones, and it says you have to answer in simplest radical form. You cannot answer as a decimal, okay? One more time. What is supposed to be on this side? Yeah, it's supposed to be x square roots of 2, right? So it says 2 all by itself is equal to the leg times the square root of 2. How are we going to get the leg by itself? Yeah, we're going to have to divide by the square root of 2. Now, unfortunately, can we have this in the denominator? So we have to multiply top and bottom by a square root of 2. What is the square root of 2 times the square root of 2? It's just plain 2. So then what happens? Yes, we get a square root of 2 equals our leg, and it's each a square root of 2 then. Now, the 30, 60, 90 pattern is similar. It's a little more complicated. I will go over it with this class tomorrow. If I don't have technical trouble, though, the other classes will get this, so you can watch the end of the video. I'll try to re-record for those other classes. So your assignment, I will go over this with you guys tomorrow, but the assignment is in Delta Math. You have to join the Google Classroom and the Delta Math Classroom to get this assignment. Please start the semester as best you can doing what you can of the assignment, okay? If you get confused on the triangles, the patterns, we'll work on that tomorrow.